Welcome to EDU World Space.
In this question, we are given some information about the object and image for a converging lens of known focal length, and we are asked to find the object and image distances. So the first thing to note here, so we have a real object to the left of the lens. So we'll just like sketch in a thin lens, and we're going to sketch in a focal length on each side. And we're given that that focal length is 70.0 centimeters. And we are told that the object height is 3.20 centimeters tall. And then we're told that the image is 4.5 centimeters tall and inverted. So converging lenses form real images that are inverted. Virtual images are always upright, regardless of the kind of lens. So the fact that this is inverted tells us that it is real. And that helps us because we now know that this real image is on the right side of the lens and will therefore have a positive image distance. That lets us check if we get the, a reasonable answer here at the end. All right, and the fact that it is inverted tells us that we need to assign a value of negative 4.50 centimeters. So we're going to come back to our magnification equation, which has negative image height over object height equals image distance over object distance. So we can find our magnification and I get that ratio to be 1.40625 equals DI over DO, which means that we're going to be able to use our lens equation and make a substitution that our image distance is 1.40625 times our object distance. So now let's come to our lens equation. 1 over the focal length equals 1 over object distance plus 1 over image distance. So 1 over we can go ahead and plug in, actually. We can go ahead and plug in that 70 centimeters for our focal length equals 1 over the object distance plus 1 over 1.40625 times our object distance. And that gives me our next step will be to find a common denominator. So we'll multiply, let's sketch this in. So we're going to multiply this by the 1.40625 over 1.40625. And we're going to have 1.40625 over 1.40625 DO. By the way, the reason I'm not rounding this right now is so that I can have the most precise value at the end when I round my final image and object distances. Okay, great. So now we have 1 over 70 equals 2.40625 over 1.40625 times our object distance. So we can now invert this in our next step. 70 over 1 equals 1.40625 dO over 2.40625. And going ahead and then isolating dO. Well, I guess I'll go ahead and show you. We will end up taking 70 over 1 and multiplying it by 2.40625 over 1.40625. And that's going to give us a value of 119.7 centimeters. If I had rounded my factor there to 1.4, I probably would have gotten 120 even, I'm going to guess, but that's okay. And so now we come back to the fact that actually we have room right here. So now here at the end, we can take our 1.40625 and multiply it by 119.7. And that gets us 168.4. So, it's up to you where you want to round it. Oops, there we go. At 168.4375. So I'll just call it 168.4 centimeters.